The first time we arrived on Devon Island, we landed in this plane. The team was very small, we were just 4 people. And I was just completely taken aback by how Mars-like the whole landscape was.
Especially when you're flying in, it looks just like the moon base. The land is desolate.
We had to take 7 flights to get here. It's a really tough undertaking, but it's extremely fascinating.
This is a place that is barren.
Vast, intimidating.
You're rambling through areas that are quite dangerous.
It's isolated and remote and rocky, just like the surface of Mars is.
I think someday there'll be humans walking on Mars, definitely.
My guess is that the first people who land on Mars will say something to the effect, "Oh wow, this looks just like Devon Island, where we trained." My name is Pascal Lee. I'm a planetary scientist. I work with the Mars Institute and the SETI Institute. Devon Island is the world's largest uninhabited island. It's cold, dry. I call this place Mars on Earth. We find exactly the same looking canyons, valleys, and gullies here.
It's just very desolate and empty of everything. Here, there's no road to go back to.
There are no streets, but there'll be street view. My name is Katya Minitenko, and I am working on all things related to Mars and Google, sort of bridging the two things.
We have an amazing team from Google. We are adding our base camp and our surroundings to Google Street View.
We're going to be able to see it and welcome everybody to Mars.
I've been associated with Pascal ever since we began this project back in 1996. As camp manager, I'm responsible for the smooth running of camp and getting all of the equipment up and running and operating smoothly. So one of the first things I do when I get up in the morning is start the generators, start the water pump, and sometimes I cook breakfast.
All right, dig in.
In the meantime, the people in camp are just starting to wake up.
Yeah, we've been getting up at 6 every morning. Steve and I and John.
Wake up every morning, brush your teeth, give yourself a bath using baby wipes. You go to breakfast, you're constantly covered in many layers, you're wearing gloves. It is the high Arctic, so temperature is always down right around freezing. I've been helping out with the Humvees, working on those, and it's a new experience for me.
I'm David North, and I'm an engineer at the NASA Langley Research Center. I'm happy to be part of the science and research that will someday lead to a younger generation landing on Mars.
Altitude 502 feet.
There's something on the other side of the hill there, too. You see this is green stuff over there?
It's very difficult to fly on Mars because the atmosphere is so thin. So the trick is to make your vehicle very light. And this vehicle is a vertical takeoff and landing vehicle. And the idea there is there are no prepared runways on Mars, so you have to land in such a way that you can land in rough terrain or terrain that doesn't allow for rolling landings. Tipping over is definitely an issue for this aircraft. So there's one of the things we're learning about this aircraft is maybe the wheelbase needs to be a little bit bigger, particularly if it's a robotic aircraft and there's no one there to fly it.
I bring my dog up here because he has a very specific role. We are in the Arctic. We're not at the top of the food chain. It's the polar bear that's at the top of the food chain. And so we have a dog here as part of our bear wildlife deterrent system. The hope is that my dog would be able to sniff out a bear and not attack it, but distract the bear and buy us a little more time. The science is only part one of our work. The other part is we're learning how to explore. Okay, so today we're going to Astronaut Canyon. It's spectacular, and it's really very similar in morphology to what we see on Mars. It takes about 2.5 hours to get there.
I think this could be one of our panos for the Voyager story.
We're going to be out on an ATV ride and heading far away from the habitat, and all around you, 360 degrees, you see nothing but rocks.
So the way you would explore Mars is driving your ATV wearing a spacesuit, and while you're riding, you're connected to your reserves so that they will recharge the oxygen tanks and the batteries in your backpack. Your ATV would be a self-driving robot that would follow you in your exploration on foot. This is why we're here. It has exactly the profile, the slopes, the topography, if you will, of some of the canyons we see on Mars.
I am actually collecting 7 to 10 panoramas to create a Voyager story.
It's not just spending money to build a rocket and train people and build hardware and fly to Mars with the fuel. It's the fact that this will galvanize an entire new generation of people to go into science.
We're standing where no one has ever stood before.
This is a place that pushes us to some limit. It's a perfect place to train for Mars because it's a lot more forgiving than Mars. You can make your mistakes here so that by the time you go to Mars, you won't.
The winds are so strong. You have to be always on the lookout, so it's a little weary.
What we're going to do with the rocks that we collect is to try to figure out what hit here. We still don't know if it was an asteroid or a comet.
And so what are you hoping to find?
So we're going to be looking for traces of an extraterrestrial signature. So for example, rare earth elements.
Oh my gosh, stunning. I don't think I'll ever look at the rock the same way.
It's a desire to know more and to delve into our past and delve into our future.
I think it matters for new people looking into either planetary geology or engineering.
Studying space and astronomy opens up your mind. It's almost like traveling. You understand so much more about the physics that surround you in your everyday life.
So this is one of the first generation concept suits for Mars. To go to Mars, you have to have a good spacesuit. And right now, we do not have a spacesuit that is going to be able to work on Mars. You cannot hop around with a spacesuit that heavy. And so part of what we're doing here is to find ways to reduce the mass of our future spacesuit for Mars.
It's heavy, a little surreal. It really feels like you're somewhere else. I can't believe I'm wearing one.
I don't find Devon pleasant in spite of how often I come here. I don't come here because I somehow relish the discomfort that we have here. You know, I am cold. You know, I miss my family. But somehow this place has a dimension to it that makes me think that, hey, this is all worth it. This is so close to making it happen.
I hope you see the images of it and you really want to go there. There's so many stories where street views encouraged or moved people or inspired people to do something extraordinary. And even if one person get more interested in studying other planets by just looking at street view, I'll be really happy.
It's part of our nature. I think we always have the yearning to explore.
I think when we think about going to other planets or colonizing them, we tend to think, why would you want to go there? It's cold, it's rough. Well, that's the same thing the people in the old world said 400 years ago. But maybe 1,000 years from now, when people have colonized Mars, they'll think, well, this is normal. You know, I live on Mars. So what?